next pass, we will see the sun's environment in a period of increasing solar activity. There will be more sunspots, presumably more solar flares, and so by completing another pass, we will have a better understanding of the total environment under all conditions. You know, it's a first, and it's a once-in-a-lifetime opportunity.
Space, a final frontier.
In June 1994, the Ulysses spacecraft began an expedition over the poles of the Sun. Its mission?
To boldly go where no man has gone before.
To study the Sun and the solar atmosphere expanding into space.
To reach the high solar latitudes never before explored, the spacecraft must use the gravity of an immense planet, Jupiter, to bend its flight path out of the plane in which the planets orbit. Looping back inward toward the Sun, the spacecraft will then journey on to the Sun's southern pole.
Ulysses was launched on October 6, 1990, aboard the Space Shuttle Discovery. 9 science experiments studied the solar wind and energetic particles streaming outward from the Sun's corona. The experiments will also study cosmic rays entering the solar system from interstellar space.
Ulysses is jointly managed by the European Space Agency and the National Aeronautics and Space Administration. The Europeans built the satellite, NASA provided a launch vehicle, a power source, and is currently tracking the satellite on its way to Jupiter, where it'll pick up a gravity assist, which will take us over the Sun's south pole, by the equator, and then on to the North Pole.
The main objective is to study this vast, complex system, space system, called the heliosphere. It consists of 3 parts. Originates with the Sun. The whole top or part of the upper atmosphere, the so-called corona, is actually expanding out into space at very high speed. And it carries magnetic fields with it, and it pushes the interstellar medium, which exists throughout space between the stars, away from the Sun. And it creates a huge bubble within which the solar system is located.
With over 4 billion miles already logged, the Ulysses team plans to continue shedding more light on the Sun for some time.
But to all good things must come an end. With power from its radioactive isotope generators steadily decreasing, it has become an immense challenge to keep Ulysses warm enough to prevent its hydrazine fuel from freezing. Since 1999, energy-saving measures have been implemented, sharing the power between the science instruments, but the final crunch came early this year.
Switched it off. It never came back on. It's sad to say goodbye, but it served us well and certainly lived up to its mythical namesake reputation.